Okay, so welcome back. So we are in the 9th week now. So if you think about, this is a 12-week course. So out of 12 weeks, we have finished 8 weeks, and we are in the 9th week. So that means we are in the last 1/3 of the course. So we have already finished 2/3 of the course. We are in last 1/3 part of the course, and I hope that you are enjoying the course so far. So we'll continue our discussion with the last video. If you remember from the last video of the last week, for the week 8, I was showing you the details of a landfill, how the liner is constructed. I also showed you some pictures towards the end where the waste, the landfill, the liner requirement, because of the clay was not available locally, so the the clay was brought from outside, compacted. We talked about the Proctor compaction, the optimum moisture content. We also talked about the liners, HDPE liner especially, and then the liners has to be welded. So we kind of ended at that particular point. So now once you put the liner in place, what you are doing is you're putting an impervious layer. So if you put an impervious layer, what will happen? The leachate will get produced. So once the leachate is produced, why the leachate will get produced? Because once during the operational period of the landfill, the cap of the landfill is open, because you can put the garbage in. So when you put the garbage in, if it's a rainy season, even the water can come in. So if it's any rain event, you will have the water coming into the garbage. So that will pass through the garbage and becomes part of the leachate, and it will flow down because of gravity. And at the same time, waste itself has some moisture, so that will also percolate down over time. And as the part of anaerobic degradation of the waste, you also have moisture being one of the byproducts. So there are different sources of this moisture, and ultimately all these moistures together is called leachate. So leachate will start coming down, and since we have this impervious layer, leachate will start building up because it cannot move down. So it cannot say, if it starts building up, the problem is if it becomes too high, and if the hydrostatic pressure becomes too big, we have the landslide problem. As you see during the rainy season, every time during the monsoon and the rainy season, you hear about the landslide happening in say Uttarakhand or certain hilly areas. It's because the moisture getting into those pore spaces and compromising the CN5 value that you learn in soil mechanics class. So that leads to the failure, the interaction between the soil particles are not good, strong enough, and then they slip, and then you have a failure. So similarly in waste, if you let this water pound up, we'll have the slope stability problem. So we need to remove this water, and this water needs to be removed and treated. So that's where the leachate collection system comes in picture. So for landfill design, as of today, there are few aspects of landfill which is very, very important. If you want to become a landfill engineer, you have to be very, very good knowledge about leachate collection system, of course the liner system, then leachate collection system, gas collection system, stormwater protection system, and the groundwater protection system, and we'll talk about those. So let's talk about the leachate collection system first. So how we remove the leachate from the landfill? We try to drain as much as possible by gravity. Now we don't want to use pump inside the landfill, for the obvious reason. So we want to drain as much as possible by gravity, which is the liner system and pipes. So but we will have a slope, we'll have a slope, and I'll show you some pictures of that. So there will be a slope, and then we try to drain as much as by using the gravity, and then we will have the pump from the lower point, minimizing the penetration through the liner. We don't want too much penetration through the liner as well, because the more the penetration, more chances of moisture getting into the landfill, and we want to minimize the use of pump inside the landfill, because for the obvious reason. So once the waste is put up and you have the pumps inside the landfill, those pumps are inaccessible. So if something happens to the pump, you cannot do anything about it. So in case where we may have to use some of these pumps, what we do is we add some redundant pumps. So rather than if requirement is 2 pumps, we provide 3, so that even if one goes bad, we will have others to take care of the work. So the leachate collection system is, since in the liner system, the leachate flow is intercepted. So in the liner system, we are intercepting the leachate flow or impeded by the liner. So then it should be removed. That's what I'm talking about. It should be removed from the landfill by the use of the leachate collection system. Many times you hear the CS. This is the short form you see for leachate collection system. So that's the abbreviation used for that. So the leachate collection system is kind of opposite to the liner system. So if you remember from the liner system, we had a impervious layer, isn't it? We put a impervious layer of high density polyethylene with the clay at the bottom that you saw in the previous video of the last week. But now since we have on top of this impervious layer, we doesn't want this leachate to be pounded up too much. So we put a drainage layer here. We put a high permeable layer, and then we put several pipes, and I'll show you the sketch of that. So we'll have several pipes, and those pipes will collect all the leachate, and the leachate will be taken out. So here it's a high permeability layer designed to transmit leachate from the liner. So that's what the leachate collection system is all about. So let's we'll look at some. So this is how it will look like. So we had this liner system at the bottom. This is the liner system at the bottom, where you had this high density polyethylene and the clay and all that thing at the bottom. That's your liner system. We already saw that. And then we have the leachate collection system on top of here. So what is this leachate collection system? We have a series of pipes, and these pipes have actually perforations. There are perforations here. Perforation means the hole. They have the holes in there. So the leachate from this side, and similarly from this similar length from the other side, it flows in here. It will be flowing in from this side and as well as from this side. So that's how the leachate will flow in, and then it will get into these pipes. And what you are looking at is a cross section. So you're looking at the cross section of the landfill. So there will be the pipe is actually going. You can think about that there is a long pipe. So it's what you're looking at here is actually the cross section of the pipe. So this pipe is, so you can think about the pipe is going into this, into the screen for a long distance, and then you have a header pipe where all these pipes. So say if this is my thumb, if it signifies a pipe, there are several pipes like this, and this is my header. This is the header pipe, the main pipe. So there will be one pipe here, one pipe here, one pipe here, and then based on the width of the landfill, we'll have several. And the spacing of the pipes we have to design. That depends on how much leachate is being produced. So we have to do some leachate like leachate volume calculation to find out how much space. And for all that, if you remember from the liner requirement, there should not be more than 1 feet. There should not be more than 1 feet head on the liner. So here the liner again we put a slope. The liner is sloped, so leachate collection system is also in a slope. So it will essentially flow through gravity, and the slope is 2 to 8%. When I say 2 to 8%, that means if it's an 8%, you have 8 vertical and 100 horizontal in terms of the unit. So it's a highly, and it is not to scale. This is actually this slope is much more than 8 to 8%, but this is just to show you this is what it means. So it's a very tiny slope, not too much. It's a tiny slope. The sketch here is not to scale. It's just an illustrated illustrated sketch. Don't think that this is 8% slope. What I am showing you over here. Actually, it's much more than 8%. It's just to show you how it looks like. And then it will get connected to these pipes, and these pipes over here will have this area will be filled up with some sand kind of material. The reason for that, and this is a geotextile. The line that you see on top is actually a geotextile. Geotextile acts as it's basically acts as a filter. So it doesn't let, so this thin line that you see is a geotextile that acts as a filter. It only lets the moisture come in, only lets the water come in, not any of the gluey kind of material with the leachate, otherwise it will clog the pipe. And then you have this sand here, which prevents it from getting any clogging from the like a waste coming into these pipes and all that. So this is, and that's this this is wrapped around, and I'll show you the picture, some picture of that as well. So this is how this thing look like, and as you can see, this is mostly what is known as a sawtooth design. So this is in an area of sawtooth. Remember that SAW that we use for cutting the wood. So this is like a sawtooth design where you have so there are other designs out there too. So when you work in a landfill industry, when you talk to some other landfill engineers, you talk about the leachate collection system. Many times you may be like they talk when they are talking in a waste conference or other places, they will say, oh, whether you have a sawtooth design or whether you have a fishbone design. The other one more popular, not as popular as sawtooth, but other popular method of leachate collection system is a fishbone design. The fishbone design is where, as you remember, especially if you're from fish eating place, you know that the fish has a central bone. Most of the fish will have a central bone, and there will be a lot of side bones. So that's what the side bones are there, and this is the header pipe. That's the header pipe for the leachate collection system, and then you have the side pipes, which is very similar to how a fish bone look like. So if you have a smaller fish where you get a full fish fry, and then you take all the flesh out, just look at the bone structure. That's what the fish bone design for leachate collection system. So that's is also called like a fish bone design for leachate collection. So this that's the header, that's the middle pipe that you saw, and this is your geotextile that I was talking about. So this is the geotextile part. That's the black part that you see is the geotextile, and then this is the pipe. The pipe has perforations where the waste is getting collected. Oh, sorry, the leachate is getting collected. That's the sand in there, and it is wrapped into this geotextile, and so to prevent it from getting clogged and to save this pipe for any like a any breakage and all that. So this, since it's a wrapping kind of design, it's also called burrito design. Burrito is a very famous Mexican food, which is actually a wrapped food. So that's why it is also called a burrito kind of design. So this is how it looks like. So then there is another thing used is a Geonet. Geonet is a synthetic HDPE material. It's used for drainage of liquid. And Geonet, if you remember from the previous video, we were talking about the double liner system with a leak detection system in the middle. So for the leak detection system, we use this Geonet. So we use this Geonet for the leak detection, where it has more transmissivity in the horizontal direction. So it allows the water to flow more in the horizontal direction than in the vertical direction. So it helps in terms of finding any leaks and other stuff, and then let the water flow through and getting collected in the leak detection system. So the Geonet is used for that. So this is another, you see the picture of Geonet right there. So we had the liner at the bottom that you saw from the previous video as well. That was the liner at the bottom, and then you have this leak detection system in the middle. That's the Geonet that is being put in place. So there will be pipes in between here, which will remove that. So that's a closer view of the Geonet. And then we have this geotextile, which is a geosynthetic textile that is used in many civil engineering application. I showed you the wrapping of those pipes with this sand in between. So that's the geotextile, essentially as a filter. It separates fine, what it does, it separates fine granular material from coarse granular material, plus it allows water to flow through. So basically it acts as a cloth filter. So that's what the geotextile does. So that you can have this is your like in tow drain, and then you have the another area where you can use for the stormwater system. For the stormwater system, you can use these kind of pipes where water coming into the stormwater after say rain event, whatever the water is coming in there, you can get this will get into this drain, and then you can use these pipes to drain those water. So this is called a tow drain, which is it's at the toe, it's at the bottom of the landfill. That's why it is called tow drain. And if one thing you can see on the picture towards the back, you see those white stuff, those are actually the birds. And as I told you earlier, if you really want to watch birds in many countries, you go to the landfill and you will find lots of birds there. So those are the birds you see on the back over there. So then the leachate is then, so all those pipes that we saw, those pipes are actually, you can basically, those pipes are coming and joining this pipe. Let's see, oops, sorry. So these are the pipes are actually coming in and joining to these pipes over here. So those basically you will not be able to see it because it is on the other side of this pipe. So this is, if you look at the cross section of the landfill, and if you are at the edge of the landfill, so landfill is over here, so all these pipes are coming, and basically this is my header pipe. Say if I take this as a header pipe, so pipe is coming and joining here, joining here, joining here, and that's how it gets into this header pipe. And there is only one place where it is coming off from the liner. So there is only one breakage point one point where the pipe has to come out of the liner. In this area we are using all gravity drainage. So once it comes out, it goes to a pump station where the leachate will be collected, and then it can be sent for leachate storage and treatment. And this leachate treatment, or it's the same as wastewater treatment. So if you have taken an industrial wastewater course, so this leachate treatment is essentially same as the industrial wastewater treatment. So it's nothing, the same concept are used here as well. So this is some pictures of those leachate wells which you saw in the sketch earlier. So as you can see that there is a landfill on the other side of this berm. We have a this liner system, leachate collection system, and then the leachate collection system pipe will come into these and the leak detection system pipe will come into this particular well. So that's how the leachate will be, and then we will put pump in these wells, because these wells will be accessible. These wells will be accessible if we are doing the landfill operation. So this is another picture of those like wells. And then you can see the picture from inside. You see the pipes coming in. Right now it is not an operational landfill, it's just a stormwater, some concrete mixed water you see over there, and that's but once the leachate will start coming in there as well. So then how do you predict the leachate generation? I told you that it depends on the spacing. Like when we come up with those pipe, say let's back up. So in terms of the leachate collection system, what we need to design, it's very similar to what you have done in a hydraulics class. So you have to have set of pipes, because there is the leachate being percolated through, either through the rainfall or through the garbage decomposition or whatever reason there is some inherent moisture there. So all these moisture will come down, and ultimately if this is my liner system, it will start ponding up. So my job as a leachate collection system engineer is to design a series of pipes. So I have one pipe here, then I have another pipe, then I have another pipe. So I will have several, like 1 pipe, 2 pipe, 3 pipe, 4 pipe, and then I have to have a series of pipes. If we are looking at a cross section of the landfill, we'll have series of pipes. So when I say series of pipes, that means I need to find out the pipe spacing. What should be the pipe spacing? That's one parameter we need to find out. Another important parameter we need to find out is what should be the pipe diameter. So what should be the pipe diameter, and not only the individual these pipes, and also for the header pipe. So if everything comes and joins this header pipe, so once all these pipes individually over the cross section of the landfill comes and joins to this header pipe at the end. So what should be the diameter of this header pipe? So all these things we need to predict. We need to calculate. That's as part of the leachate collection system, and then we need to design accordingly in terms of, and then we decide whether we go for a sawtooth design, whether we go for the fishbone design. That also depends on the geometry of the landfill, and one is more popular in one area, one in other area. So it doesn't matter. Bottom line is you have to remove this leachate from the landfill and take it to a treatment plant, and doesn't let it go into the ground. So get the prediction, like how much the pipe is spacing as well as the pipe diameter. One of the input parameter will be what is the volume of leachate we are looking at. How much leachate is we need to manage. So in terms of how much leachate we need to manage, the one thing we have to do is we have to predict, because we don't know how much leachate will be produced, say over 35 years period or 30 years period over the life of the landfill, or how much leachate will be produced every year. Ultimately we need to look at the flow in the pipe and everything. So that's in terms of the leachate production, we have to do some sort of prediction, because we don't we have to predict that, because this pipes and everything is done first, then the garbage is put on. So we don't know as sure how much leachate will be produced. So there has to be some design for that, and to find out this how much leachate will be there is a method out there. There is a model which is used, which is called HELP model. So as I said earlier, we must estimate, we have to estimate how much leachate is generated to design your landfill. And for that we use what is known as how much is a HELP model, which is hydrologic evaluation of landfill performance. This was developed by US Army Corps of Engineers. Many of the things that we know as of today, it actually started from US Army Corps of Engineers. So this is again US Army Corps of Engineers. They had come up with this help model. The software which is used for help model is available for free. The older version, the newer version, you may have to pay some money, but the older version is out there. You can download and you can do that. But how this software works, we'll try to understand that a little bit. So in terms of the very basic of how this help model does, help model is nothing but a water balance model. So it is essentially a water balance. So you have to look at a conservation of water basically, like conservation of mass. So you need to have this water balance. So in terms of the water balance, what we are looking at. So there will be certain input and certain output. So this orange rectangular box, if that is the landfill, if this orange rectangular box is our landfill, we have certain input, there is a precipitation input, and then we have some like a moisture inherent in the garbage. So that is also like included in there. And then we have some, what are the like a output, going out of the system. We have evapotranspiration. We have some stormwater runoff, which is it's going there. Then this is the flow of the leachate, and there could be some leakage happening into the below ground. Usually there should not be any. So, but I should not say usually. Like ideally there should not be any. But this is the how we look at. So for each of these parameters, we need to find out what are the values and then put these values into this model, and then we try to predict what will be the value of Q. So we can write down the equation where we try to do the balance, and then we can come up with the value for Q. So to do that, what we do is actually we look at we'll come back and spend more time for each of those components. We break it down to like a calculation of how those parameters are calculated. So which will come back in after a few slides. So in terms of the leachate, first one thing is the leachate quantity, another thing is the leachate quality. Leachate quality is important for its treatment, isn't it? When you try to go for leachate treatment, you need to know what kind of leachate it is, like whether you should be able to treat it. So leachate can contain many compounds, and the quality of leachate will depend on what kind of garbage that particular landfill is accepting. So based on the quality of leachate is dictated by the type of waste. For MSW, the leachate quality is very much dictated by the phase of landfill stabilization. So there is also based on what is the phase of landfill stabilization, in which stage the landfill is in terms of aerobic phase or anaerobic phase, methanogenic phase. The quality of leachate will change based on those different phases. So these are some of the waste stabilization phase which we talked about, I think, in the very beginning as well. So the research have been done in different places in the world, where they have come up with this. They describe the different phases of landfill stabilization. So different phases of landfill stabilization is defined, and we'll go over that, and this is a simplified version of that. So if you look at a simplified version of the different phases, which initially we are talking about, it's a preliminary aerobic phase. So now what we mean by this preliminary aerobic phase? So you have this landfill which is accepting garbage, is still open to atmosphere. So in between garbage you may have some air pockets, and since it is open to atmosphere, it is accepting more garbage. So you have the interaction with the oxygen happening all the time, the oxygen present in the air. So there is an interaction of air with the garbage happening all the time. So the things are a bit aerobic in the system. So you have this aerobic like a situation at the first, and then as you put the cap, so if you think about, this is the landfill place, and then as you put the cap up, as you start putting this, as you put the top cap slide, and then what happens? Because you stopped the supply of oxygen from there. So once you stop the supply for oxygen, and then as the landfill depth also starts, like you have a layer after layer, so these bottom layers are already under anaerobic condition, only the top layer will be exchanging air with the atmosphere. So but once you put the cap up, the whole landfill starts getting anaerobic over time. So once it gets anaerobic, And during the decomposition of the waste, what happens is this big molecular weight organic compounds, they get converted into different forms of acid, and that's called volatile fatty acids. You hear a term VFA. So VFA stands for volatile fatty acid. It's a group of acids: acetic acid, propionic acid, butyric acid, like isovaleric acid, and there are different types of acids out there, and they are all together is called volatile fatty acids. So they get converted to VFA. So more and more acids are formed, and you have the anaerobic group of bacteria which is active and making those things possible. So once these acids are formed, the next thing what happens is finally this acid gets converted to CH3COOH. So this particular thing where this there are two group of bacteria. First we have this acidogenic, we have acidogenic bacteria, and then after that we have this acetogenic. So there is a TO and there is a DO. Earlier we have the DO, here we have a TO. So there is acetogenic bacteria actually converts everything to acetic acid, and from acetic acid you start getting methane being produced by the methanogens. That's called methane forming phase, or methane forming bacteria, which creates methanes out of that. So that's how things typically work in a landfill. And then once the waste degrades over time, and what happens is say you had this like a landfill where you had some waste, and the waste degrades over time. So the solid inside here is getting converted to either gas or to liquid. So the solid mass is reducing. So if the solid mass is reducing, if you think about this as a huge polythene bag where you had things all nicely compacted, now you are losing some of those mass. So what will happen? You will start having like air pockets in there, because the water, and then the air will try to come into those air pockets. So if there is any breakage in the liner, or somehow air can intrude through, so air can come into those packets, and that's what is kind of envisioned in this final aerobic phase, because the air getting into those pockets, it can create aerobic situation. So that's how the different phases of landfill stabilization can be explained. And based on the landfill phases, phase of stabilization, you will have your leachate characteristics as well as the gas characteristics keeps on changing. So if you look at here, initially we start with a low, like a slightly like a pH of around 5.5, something around that, or maybe slightly more than that. You start from there, and then as you have more and more acid being formed, the pH will have a tendency to go down, because pH more like low pH means acidic condition, then very high pH means alkaline conditions. So as the acids are formed, the pH goes down. So pH goes down, and then as the acid is being consumed to convert it into methane and other products, it starts getting back into the normal range of around 6.5 to 8.5. That's the typical range for the pH. And similarly for BOD, initially it's a low BOD to start with, although there are a lot of organic material, but they are not readily available organic material, although it is there, but the microorganisms cannot access it. Once this high molecular organic compounds is broken down to low molecular organic compound, the microbes get accessibility, so the oxygen demand goes up. So that's why you see a spike on BOD. And then since this lots and lots of acids are produced, so you see a spike of VFA as well. And then once these acids are started getting consumed, so then you have your BOD requirement goes down, and if you reach a mature leachate phase where it's kind of mostly treated, your BOD requirement will still be very, very low. So that's in terms of the pH. Similarly for the gas, we'll wrap this particular video with this particular last slide. Similarly for the waste stabilization in terms of the gas, initially again if you have a preliminary aerobic phase, aerobic means it has the air, so air is there. So air is there means we have, if the air is present, that means we will have some nitrogen, we will have some oxygen showing up. And then as you have waste started degrading and anaerobic condition starts taking place, or even before that aerobic condition is taking place in terms of waste degradation, you start the peak at like CO2 starts picking up. So CO2 will pick up, and then you will have a pickup of methane as well. So methane and CO2 both are kind of nearly 55-45% gas in terms of biogas, and there are some other gases in there too. Under the hypothetical scenario of final aerobic phase, you may start seeing another oxygen coming back again, nitrogen coming back again, and this methane and CO2 kind of going down. So that's those are because methane is a it's like a reduced product. It's not an oxidized product. Methane is a reduced version of carbon. So that's in terms of how this particular thing works. Okay, so let's with this we'll try to, let's see what we have. Okay, so let's stop here. So in terms of so what we have done so far in this particular video is we looked at this how the leachate is collected. We talked about what are the basics of leachate collection system. We also looked at the model, like a very brief overview of the model. We'll come back and spend some more time on the model in one of the videos this week, and how this the basic concept around this particular model. And then we also talked about in terms of the waste stabilization, different phases, and how this leachate quality and gas quality will change under different stages of waste stabilization. So that's with that, let's wrap up this video, and then I'll see you again in the next video. Again, keep communicating, use the discussion board, and we'll be more than happy to assist you to learn this course as good as you can. Thank you.